for you today. So that's where we are today, starting our mission for you. Yes, for those of you who probably didn't hear me before, I am just saying good evening to you all. It's a pleasure being here again. Going live on behalf of CDP Laverages Services. I am quite a bit aware that some persons who are not yet on the live are maybe having dinner with your family still and friends. And it's a time and season for this. We just want to say, Merry Christmas to you too, and happy holidays. And for those who do celebrate Christmas Day. Now, I, for one, I don't really celebrate the day because of what persons, probably think it's for. I don't know when Jesus Christ was born, but I believe that he was born and he died and raised again. So his mission was fulfilled for us. But throughout the entire year, we must live and celebrate the life, death, and resurrection of Jesus Christ. So just want to once again wish you happy holidays and just want to encourage you to pray, and give God thanks for having spared your life to live to see this another um, day, And of course, it is really a pleasure, as I said before, to, you know, um, work along with you and prepare you for exams, as it is usually our mission as CDP Labs Edge Services. So sit back, relax. I know that you might be watching this after the recording, but of course, we want to ensure that we, do what we promise to do. And of course, we are getting ready for our presentation. So now we will be going through the question one questions, going through a few past paper questions, starting, of course, in 2022. Of course, you know that the 2023 year paper was not approved because it was leaked out, unfortunately. But of course, here we go, ready to continue preparation. All right. All right. So let's say my PowerPoint is ready to commence. Checking on it, checking on it. Just checking out a bit. Okay. All right, so we're going to start now. All right, so good morning once again. Good morning. Well, good morning, some countries, right? Okay, so we're going to go into commencing our lesson right now. Just want to move on from here. Give me a second here. Just give me a second. All right. So we're good to go now. So welcome to our CSEC Mathematics past paper solution um, stream lessons. And of course, we just want to say thanks again to the 800 and odd persons we have subscribed. And if you are new to our channel, we just ask that you will, of course, touch the subscribe button and subscribe to the channel. Reason being that you can be able to catch the remaining portion of our live streams throughout this year and beginning in the next year, God's willing, our lives are spared. And your life is actually spared. And we pray that both of us lives will be spared. Now, what is coming up, God's willing, we'll be going back to our competition that we used to have, where our students on Zoom, or registered students on Zoom, would of course compete with students who are our visitors to our channel. And of course, we allow all visitors to our channel to participate in the live sessions because of course, you know, how could you be a part of our subscription list and not participate? So we send the link in the YouTube chat and allow you to join the competition. And I can tell you that year when many persons joined the competition, many persons were successful, getting grades 1 and grade 2 and passes in their exams. So we want to go back to that period of time where we allow persons from the YouTube channel to participate and somewhat benefit. Now, our maths program, we now have 2 days per week. That is on a Monday and a Wednesday. Only on Wednesdays, we will be streaming our classes. And then on Mondays, we have, students who are practicing, they're doing work. Our students do get they get lessons to do on the learning management system that we use. So they watch those videos that were created for them. And of course, they have worksheet questions to do. And of course, the lesson on a Monday is very interactive. Of course, very, very interactive. And they do have past paper questions to do during the Monday sessions. And of course, it will come over into the Wednesday sessions. So if you don't want to miss out on anything, I can tell you that you can register now with CDP Labs Edu Services. Just go to our website, www.cdplabseduservices.com, or look for CDP Labs Edu, and you'll find our website and go on our own page. You can go and you can register. And if you register, you can also qualify to get a coupon of 20% discount. So a lot of things out there for you. All right, so let us begin with our first set of questions. And of course, I'm your host, Ronique Bernard. Thank you for having me. And I hope you had a good family dinner. All right. And join us tomorrow, God's willing, for day 2 action for day 2 questions. All right. So our first question here, well, this is not our first question. My bad. Yeah, this is our first question. Our first question is coming from the May-June 22 past paper. And it says using a calculator or otherwise find the exact value of 7/8 plus 1/6 divided by 2/9. Now, the first thing to observe with this question is that there are two mathematical operations in the exam question here. Two mathematical operations. And those two mathematical operations, I mean, you can tell me, it is in fact the addition sign, for some it is plus, and then you have the division sign. Now, this question is testing if you know the rule, if you have knowledge of the rules that apply in mathematics. And of course, the rule that governs this particular part of the question is that you do division before you do um, subtraction and addition. And of course, you know that you must do multiplication before you do subtraction and addition. So we're going to start with the division portion of the question first. So the division portion of the question would be 1/6 divided by 2/9. Now, what this is really asking is how many 2/9 are there in 1/6? Now, for you to understand this, um, sorry, my sincere apologies for that. I had to step away for just a few seconds. All right, well, you got some time to really think about what we're doing right here. Yeah, so we're gonna just want to for you to understand um, the concept of division of fractions before I get into the actual question. So we're just gonna look at a little example before we get there. All right, so give me some time to show you this. All right, so here we are talking about division of fractions. We said it's good, we're making it easy, won't it? So we're going to look at maybe one or two questions using manipulatives for you to get a feed and understanding as to how they do division of fractions and why they do it that way. I'm sure many persons are not sure. Now I'm seeing now 2 or 3 persons in our live. So welcome to CDP Library Services once again. I'm not sure what is your name, but if you want to leave your name in the chat area, then feel free to do so. So you can be recognized. And of course, you can share the link with a friend or a family who you know probably doing the exam in January, just a few days from now, or doing the exam in June, May, June, a few months from now. So let's look at, we're going to use our fraction circles for now. All right. Now we have a whole right here. Good. So we're going to look at, say, a question, let's say one, um, let's say one, let's say a quarter divided by 1/3. Now, what is being asked right here is how many 1/3s are in a quarter. So let's look for quarters then. Let us pull out the quarters. Now here we have the quarters. And here we have the thirds. Good. So we want to know now how many thirds are in 1/4. That's what we want to establish. Now, as it is, it might be difficult to tell. Well, mm, let us change it around. Change it around. Pardon me for a bit. Change it around and ask instead of that, how many quarters are in a third? Make it that way. Now, here we are. As you can see, a third is greater than a quarter. Good? A third is greater than a quarter. But how many quarters are in 1/3? That is what we're really asking. Now, we can we can we can ensure that both shapes are the same size. the same size. Now, let us do something with that. So we have 1/6 right there. Still not the same size. Let's continue. Still not the same size. Still at the same size. Let's continue. Now you notice now that they are now the same size. Good. They are now the same size. So we can say three of this is one set. So three 1/12s is one set of quarters, one set of a quarter. And one set of that can go into 1/3 only once. Let's look at it. You can probably turn it, switch the angle, then fit properly. There you go. So we have it, one set of it being covered. So the first thing we did was to make both of them be the same sign. In your case, you would say perhaps the same denominator, right? So here we are, one set. But we notice that a portion, one out of the four parts of the third, is left. But we have to find out now what fraction of this is that. So let us see. So a quarter can go into a third one time, remaining what? 1/12. Let us see now, using the method that you were taught. You were taught that 1/3 changes, and you can see why they say multiply. You can see why they say multiply. Good. Now, it's not even 1/12, actually. It's not even 1/12. Not even 1/12. Let me show you before I go to the abstract way of doing it. Now, one portion is 1/3 of this set. So this 1/12 here is 1/3 of this. Got that? The 1/12 is 1/3 of this. So therefore then, the answer should be 1 1/3. Good. So how many quarters are in 1/3? One set and a third of the quarter. We're going to show you how we get a third of the quarter. We're going to get to that. Let's just take our time. We're just getting to understand division of fractions, right? Just getting to understand division of fractions. So watch this now. So note we said is one set and a third, because one out of the three is 3/12s, make 1/4. But these 3/12s can only go into this one time. Good. Remaining what? One out of the three, because 1/12 is a third of a quarter. We're going to see that. So look at this now. So we have 1/3 now. Change the sign to multiplication. Invert that. And then your answer will be 4/3, which is the same thing as 1 1/3. Good. I told you the answer is 1 1/3. So we know all got this one, right? But you don't know all got the third, right? All right. Let us see. Now notice that we are saying that the 1/12 is a third of a quarter. So 1/12 is a third of. So what is now? 1/3 of a quarter. And they say, where you say half in mathematics, it means to what? Multiply. So 1/3 times 1/4 is going to give us what? 1/12. So 1/3 of a quarter is 1/12. I hope you got that. Now, so how does this relate now to the exam question? We're going to look at that. So please note the first thing that we did. The first thing that we did was to make both denominators the same. All right. Now I'm going to hope you can screenshot this and see that. You can watch over the video to see where I went, where I started, and where I ended. So let us go back through it a bit. Just wanted to get the full understanding of the division of fractions right there. Where they all get this thing from, right? As I say, if you want to develop your mathematics competence, you can register with CDP Labs Edu Services. Now, the first thing is to make the denominators the same size. As you can see, 112. So, let's do that. So 1/3 is 4 12s. And then a quarter is 3 12s. Good. So we did that. Then now, what you can do to make life easier is separate the 12s. So it's 4 12s. So you can say, okay, 112. You can put a comma if you wish, you can list them. Another 112. Another 112. Good. Comma. Another 112. Good. Comma. Now note, we can draw a line right here. And we can put the 3 12s now below. 112, comma, 112, comma, 112, comma. So you realize now that the 3 12s right here cancel the 3 12s over here. Leave it 112. But that, so this one set here going to this one set what? One time. And hence we have the 1. But note that this 112 is a third of the set. So it's a third is remaining. And that is it. That is what we do in abstract form. But of course, let's go back to what you would have learned is that 1/3, change the sign to multiplication, then you invert it. Good. You invert it, and then you end up getting what? 4/3, which is equivalent to 1 and a third. Simple. So let us try that now with the exam question. Let's go back to the exam question and see if we can try that and see how it works. So let's go back to the exam question. So here we are at the exam question now. So we have 1/6 division sign and 2/9. Now, you will probably say the lowest common multiple, right? In this case, to make them the same size, and that would be 18. So how many 1/6 make 18? Which would be 3 18ths. That's 3 18ths, right? So if you notice now, how we get the 3 18ths? Whatever you multiply 6 by, whatever you multiply the denominator by, you must do the same for the numerator. The 3 1s 3, 3 6 is what? 18. We have our division sign again. So 2/9 now, we can multiply both sides by the numerator and the denominator by 2. So you're going to get 4 18ths. Now, if you notice now that the question is asked now, how many 4 18ths you can get in 3 18ths? And that's the question. Good question, right? So if you were to, the thing about it is that we're going to recognize that this portion is a larger portion than this, much larger portion. So the question is then, how do we get that into that? How do we do it? Now, let's look at an idea first. If we had three marbles, I was how many times four can go into three? How many times four can go into three? What you end up doing right here? So, how many times can four go into three? Now, it is less than one time that this can go into this. And perhaps the answer, if you notice now, that 4/8 can only a portion of the 4/8 can go into what? The 3/8. The question is, what fraction of the 4/18s can go into this? You're going to see. Let's look at it. So if we have 1/18 up here, 1/18 up here, 1/18 up here, and let's represent the 3/18s. And then we have another 1/18, 1/18, 1/18. So as you can see, it's 3 out of what? 4. There's 3/4 of it. 3/4. That's so it's only a fraction of it can go into it, and the fraction is 3/4. That is it. Only 3/4. So, so how many times can you get 2/9 in 1/6 is actually 3/4. And of course, you could see that. You could easily see that. I can show you that is correct. I'm going to show you how it is correct, show you the way that you know. So the way that you know is by doing this. So therefore, you'd say 1/6 times 9/2, and then you multiply across 9/12. They can reduce the fraction, and you can say 3 into 9 goes 3 times, and 3 into 12 goes 4 times. So you see, still 3/4. But for you to understand the concept, it is a 3/4 of 2/9 you can get is equivalent to 1/6. And I can prove that to you as well by showing you this now. That 3/4 of 2/9, and of is multiply, of 2/9 is 1/6. Let's see that. Now, you can say multiply across 3 to 6, 4 9s 36. You reduce it. 16 to 7 goes 1 time. 6 into 36 goes 6 times. So I am correct. All right. Hope you understand that. As I said, you can join the CDP Library Services, register with us, and so you can develop the mathematical skills that is required for you to learn how to do things like these, the way in which our students are being taught to get understanding rather than just rote learning. All right, so we have done the first part of that, which is to do the division portion of the question. And what we got now is actually 3/3. Good. We're going to add that 3/3 now to 7/8. Now, we're going to show you, sorry, this is addition. We're going to show you now, using our manipulatives again now, why you cannot add fractions unless they are the same size. Good. Why we cannot add fractions unless they are the same size. I hope you're enjoying it so far. If you're enjoying it, you can press the like button. If you're enjoying it, you can express that by, you know, clicking on our like, clicking on the like button. And of course, if you are new to our class, you can subscribe to get the full benefit of CDP Labs Edu services. In other words, educational services, right? All right. So let's look at it now. Go into our manipulatives now. All right. So we're going to clean up this. Let's clean up all of this. All right. So we have to make them the same size. All right. So that's what the question is. Question is 7/8 plus 3/4. All right. Now we can look for let's use our fraction bars instead this time. So I'm showing how to use the manipulatives. And of course, our students in CDP Lazarus services get the opportunity to utilize the manipulatives just the same. All right. So we are looking at back to the question again. It says 7/8 plus 3/4. All right. So 7/8, we'll get a whole of 8. So we can get a whole of 8. We can divide into 8. So we have 8. Now we only need 7/8, right? So split them and we'll get rid of 1. So now we have 7/8. Now we need to add that to 3/4. So it's another whole. We already have it in quarters. So we're going to split that. And then we have 3/4. Take away that. So what we're doing now, adding the 7/8 plus 3/4. If you notice now, they are not the same size. But for them to be able to be added, the rule is that you must keep them to be the same size. So there are 7/8 right here. So we're going to turn the quarters into 8s. All right. You might say, why not 12s? You could try it. But again, you have to make that the top part be 12s too. So now they're the same size. So each quarter now was turned into 2/8. So they are now the same size. Good. So remember now, we're adding 7/8 plus 3/4. So what we did was to make the two of them have the same denominator by making them the same size. All right. So now we we can now put them together. We can now put them together or count them together. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 eights. So we'll have 13 eights. But I'm going to show you something now. How we can rewrite this 13 eights. So I'm going to put them together and show you something. Now, first of all, I just put on 2 eights to that. Now, look at this. If you realize now, after 7 eighths right here, 1, 2, 3, 4, 5, 6, 7, 8. Good. I think we had a little problem here. So this is supposed to be 7 eighths. So this is 1, 2, 3, 4, 5, 6, 7. Hold on. So 1, 2, 3, 4, 5, 6, 7. Okay, good. So now put on this 2 eighths on it now. You realize that's 1, 2, 3, 4, 5, 6, 7, 8. So 8 eighths is one whole. Good. So we could now write that 13, this 13, 18 as one whole, and how many eighths left back? 1, 2, 3, 4, 5 eighths. There you go. So the answer to that question would be one whole and 5 eighths. All right. That's the answer to the 2022 question number one, the first part of question number one. All right. Now, your method is 7 eighths. And we now know that this 3/4 here is 1, 2, 3, 4, 5, and the one piece here is 6 eighths. They are now the same size. Now we can add them. And 7 plus 6 is 13 eighths. Or you can break it down and write it as a mixed fraction. So it was given as an improper fraction first, and then we now have that as a mixed fraction. All right? Hope you all understand that what we just did a while ago. So we're now going to move on to the remaining part of the question. So that was number 1A, part 1. Part 1A. Now we're going to go to now part B. Now, part B saying 8 divided by 0.4 raised to the power of 3. That's what it is saying. 8 divided by 0.4 raised to the power of 3. Now, we have to now understand what that question is asking. For those who cannot see it properly, I'm going to write it bigger. It says 8, and we see a line that says 0.4 raised to the power of 3. First, you have to understand what the question is asking. We have a line right here, and the line really means division. So you can rewrite the question if you wish and say 8 divided by 0.4 raised to the power of 3. Now, the 0.4 raised to the power of 3 is an expression of a number, or expression of a quantity, rather. Now, the 0.4 raised to the power of 3 is written in two things. One, a decimal, and an exponent. So the decimal part of it is 0.4. The exponent is a power. It is raised to the power of 3. So now we're going to now rewrite it even further. And you write the question so it is easier to use. So 8 divided by, now 0.4 is the same thing as what? 4/10 raised to the power of what? 3. That's really what it is. Now, you can now work out the cube part of it. You can cube it now. And of course, when you cube it, you're going to say 4 times 4 times 4. And let's see how much that is equal to. So we're going to cube it. Um, can I come up here? All right. So let's cube it. So we have 8 again divided. So it's going to be, when I say cube, I mean 4 times 4 times 4 over 10 over 10 over 10. Let's see how much that is equal to. All right, so that says 4 times, if we take out a calculator, 4 times 4 times 4, which is equal to 64. So let's use the eraser and remove this portion of it. So when you rewatch the video, you'll see that. Some of you can, you know, carry the video down back, then bring back forward to see it. So this is now can be written now as 8 divided by 64 over 1,000, because 10 times 10 is 100, times 10 again is 1,000. So of course, this is asking you now, how many times, how many 64 over 1,000 you can get out of 8. Now, 8 is 8 all. 8 is 8 all. Now, you can again make them the same size. We can again make them the same size. Remember again, we can make them the same size. So you can write the 8 over the 1. And to make them the same size, again, we must make them have the same one, denominator. So you realize the question look hard, but you're applying your knowledge to the question, students. You're applying the knowledge to the question, the line. So first of all, when in the exam, don't let your anxiety stifle you. Don't do that. Don't let your anxiety stifle. That is not going to be of any benefit to you when you let your anxiety stifle you. Don't do that. All right? It's not wise for you to do that. So what you should do is ask yourself the question, what can I identify? What do I know about what I'm looking at? And I said literally looking at. You know the number 8. You know the line means what? To divide. So you can rewrite the line as a division sign. You know that 0.4 is a decimal. And you know that the 3 at the top means how many times you must multiply decimal by itself. You can rewrite the decimal as a fraction. So that's 410. Rewrite it. So we can say, all right, you cube in 410. 410 times 410 times 410. So it become back to similar to what we did earlier. Right? Make sense? So now we can make them the same size. How do we make them the same size? All right. So of course you can multiply the 8 by 1,000. So it becomes 1,000 divided by 1,000. So now we now have them being the same size. They're now the same size. Good. Now, of course, we can break this thing down further. We can break it down further. We can ask ourselves, what is the highest common factor of 64 and 1,000? And then we can use that to reduce a fraction. All right. So we can do it this way. All right. Now we can break it down some more. And we now have, or we can simple do the inversion, your style, because we got the understanding of the concept already, right? To make this much easier. All right, so let us see. All right, so there's a big number. So let us work with it this way. 8,000 over 1,000. Can I erase something here? Let I erase this. As I said before, you can push the video back further so you can see. If you didn't get the first part, you can get it before you come back to this part of the video. So here we go again. So we're going to write over 8,000 divided by 1,000. And then we can multiply now. And now 1,000 over 64. Good. So we can say now this divided into this. And so now what we have now is 8,000 over 64. We can reduce this now as a fraction and say 8 into this goes 8 times, but 8 into 1,000 goes 1,000 times. And then we can further break this down and ask ourselves the question, how many times can 8 go into 1,000? And 1,000 divided by 8 is equal to 125. So the answer is 125 for this part of the question. All right. So I hope you would have understood how to do this part of number one, May, June 2022. All right. Hope you understand that. If you understand that, click on the like button. Good. If you want more, you want to cover more questions, encouragement, sweet know what? Labor. So subscribe, click on the like button. And of course, you'll see more of these lessons coming out where we make the questions easier for you to get understanding as to how and what these things are and how you're supposed to approach the exam type questions. So now we're going to move on to the next part of the question. So in both cases, you have to have a good knowledge of fractions, or to convert from decimal to fractions, and of how to use the exponents. All right. All right, so we're going to move on to our next question. Now, this question, for some people, it might be a bit difficult. Now, you have to see what it reads. It is saying the value of the square root of 26.8 minus 2.5 raised to the power of 3 halves, correct to 2 decimal places. Now, again, this is a language. This is a language. So you have to work with it in an abstract way. All right? It's a language, and you have to work with it in an abstract way. Now you can use a calculator, good thing, because it's a paper two question. So you for some calculators, you put in the square root sign first. Put in the square root sign first. And then you put in the 26.8. And so that would be, I know you're working with 2 decimal places. So you can start. So I already find the square root of this, which is 5.1. Let's write that properly. So I'm going to write it properly. So that's going to be 5.18. Now you might be wondering, oh, get 5.18. Your calculator might be saying 5.176 and more digits behind that. But remember, it says 2 decimal places. So we draw a line after the 2. The 1 is the first decimal place, the 7 is in the second decimal place, the 6 is in the third decimal place, but we want up to the second decimal place, which is 2 decimal places. Now, there's a rule that says that is the number that comes behind in this case, the second decimal place is equal to 5 or greater, you add 1 to this one. And therefore, we get 7.18. All right? Hope you understand that. Now, sometimes we have an exponent in the fraction form. It might be a difficult task, right? Now, the 2.5 raised to the power of 3 halves can be written, can be looked at in two different ways. We can say, let's say, we can say, what if we had like 2.5 laws of indices now? Raised to the power of 1, and you do have to write the 1, multiply by the same 2.5 raised to the power of a half. They say add the indices, right? You then get 3 halves. You see? Good. So we already know that we already have the 2.5 out there already. But the 2.5 raised to half of it. How then now do we do this? You can use a calculator and put 2.5, and you have the, no, you're not going to use square root now, because if you square it, it's going to give you a certain figure. But we're not going to square it. You want to use the one that says x raised to the power of y, right? So 2.5, good. And you're going to now raise that to the power of a half, or let's say 1.5. All right. All right, that's kind of tricky here. All right, let me first now explain to you. Let me first explain to you how we'll go ahead and work with the exponentials being in halves. It's sorry, in fractions rather. So I want to show you that first. I think you need to learn that first, right? Let's look at that. How do that first. Just give me 1 second, please. We can take a little break. We're almost 1 hour. We're not even finished yet. But because I'm trying to build the concept for you so you can understand how this thing is done. So we'll look at fractional exponents at this point, right? We'll look at that now. So let's take a little break with me. All right, so fractional powers are also called rational exponents. And that is our different ways of writing roots of numbers. So the numerator is the power of the term inside the root. And then the denominator is the power of the root. How is that done? You may ask. How is that done? All right. So what we're saying, let me write it down so you can see how this is actually represented. Ready? All right. Now it is saying that you have 2.5 raised to the 3 halves power. So this is how it must be written now. You have the square outside here, which is the denominator outside, of the symbol, and the numerator is on the inside of the symbol, just like that. Good. That's how it is written. All right. That is how that is written, actually. So the question is now, how do we now calculate this expression? So this is how you write it otherwise. Good. So note now, when you are writing a number raised to a fractional exponent, how do you write the number that you can understand it? So you note now that the power of the numerator, which is a 3, is the power of the term inside. The term inside is this. So the 3 in the numerator become the power. And then now, what we have next right here is that the denominator is the power of the root. So the denominator come on the outside. All right. Now, what I did earlier was to split them for you. 2.5 times 2.5 raised to the power of 2. Now, I am going to do a little trick for you. And then you can test it for yourself. I'd rather test it for yourself. You can pause me and test it for yourself and see exactly what you'd end up getting. So let's then work it this way. Ready? We're going to work it this way. Now, we're going to work it this way now. 2.5 cube. What's this 2.5 cube? 2.5 cube is 2.5 times 2.5. And you're going to end up getting 15.625. You end up getting 15.625 when you cube it. Then we find the square root of that. That's what this 2 means. We find the square root of that now. The square root of the answer, 15.625, is therefore equal to 3.95 to 2 decimal places. Good? So when you square root this, you're going to end up getting 3.95. So all of this right here is 3.95. That's what I got. Hope you got that too. Good? All right, let's continue. Let's continue now. Now I'm going to show you now that my little technique can work. So when I split them and I got 2.5 raised to the power of 1 times 2.5 raised to the power of half. So you realize now that this 2.5 raised to the power of 5 now can write like this. So here it is now. So we have 2.5 raised to the power of 1 times the square root of 2.5. And the square root of 2.5 is what? What do you think it is? 0.5, correct? You can try it out for yourself and see. So the square root of 2.5 is equal to, actually, well, it's actually 1.6, approximately 1.6 or 1.58. 1.58. All right. Actually, 1.58. Square root of it. All right, let's see something. 0.5 times. Okay, all right. Look. So the square root of of 2.5 is 1.58. All right. You can double check that if you wish. So the square root of 2.5 is equal to 1.58, the two decimal places. All right. So we can now multiply 1.58 times 2.5 times 2.5. And our answer is still 3.95. So still work. So when you split them, it actually works. So I split them, make it look easier on the eyes, and write it like this, and then multiply it by 2.5. I'll get by the same 3.95. So we subtract now 3.95 from this. And what is that answer equal to? You can use a calculator if you wish. So 5.18 minus 3.95, and that is equal to 1.23. So the answer then for this question is equal to 1.2. Pardon me, I wrote this. So the answer is equal to 1.23. There we go. That is it. All right. That is it. So we got that right. Good. All right. Wonderful. Wonderful. So we're going to move on to our next part of the question. As I said before, if you want to learn techniques like these, then you can register with CDP Labs of the Services. And of course, you'll get practice and learn some more. Let's move on now to the other portion of the question. All right, so here we go on a different question now. So children go to a rodeo camp during the Easter holiday. Miss Reka, that's her name, buys bananas and oranges for the children at the camp. Good. So first of all, they are giving you a scenario, which you can visualize it, you can draw a picture to represent it. So children go to a rodeo camp during the Easter holiday. What time of the year? Easter holiday. For some, I think it's probably March, starting from February go down to April, there above. It's a camp, rodeo. Those persons who are from the countries who know what rodeo is, probably they have some cows, you have some cowboys riding horses and stuff like that. Um, so we can picture children traveling to the camp, maybe on a bus, a chartered bus or something like that. So you have to try to read the question in a way that you can make sense out of the question. So you know that that part of the question is not so important because there's no mathematics about that part. So that sentence is something we don't have to look at again. Now, we have Miss Rika buys bananas. So we see a lady here buying bananas and she's buying oranges. So she's buying it for the children at the camp. Now, a little math's going to take place. Of course, she spends some money to buy these bananas. And of course, when you go further down, as you can peep down, you realize that the banana is speaking about the weight of these bananas. So it said the banana costs, so we're talking about the expenses of the banana. So it said bananas cost $3.85 per kilogram. Now, I fancy what the word per means. The word per means for every kilogram, she pays 3.85 cents for every kilogram. So if it was only 1 kilogram, she'll only pay $3.85 if it was 1 kilogram. So they tell us now in some term the exchange rate, right? Now, Miss Rika buys 25 kilograms of bananas. So you can find out now how much you actually spend on the bananas. But there's a little thing right here. But she receives a discount of 12%. So she never have to pay the full amount. So she got 12% discount. How much money does she spend on bananas? All right. So this question is testing a lot of things. Ratio is involved. If you want to say for every 1 kilogram, she pays $3.85. So for 25 kilograms, how much does she pay? Simple 25 times that. You can work out how much you would pay before the discount first. You can use a calculator and calculate that. 3.85 times 25. And that would be equal to $96 and equal to $96. This is $96.25. Good. But that is not the answer. Go have a start out the discount. Because that 12% discount on this. So to find that answer is simple. Say $96 times 12 divided by 100. So you find out what is 12% of that amount. Times 12 divided by 100. And that would be $11.55. Now she's not paying $11.55. That's how much she's going to take off. She's saving $11.55. So therefore you have to subtract that from the $96.25 minus $11.55. So she gets a little discount. Good. So the subtraction, I get your answer. So $96.25. Use a calculator if you wish. Minus $11.55. And that answer would be $84.70. So the answer here, how money does she spend is $84.70. That is the answer for that part. All right, easy 1, 2, 3. So first you have to make sense of the question. Make sense of the question. Make sure that you understand the question before you do any calculation. Make it real to you. If it means you're going to draw the banana and use real money, feel free. Then the question become more lively and more easier for you to do. All right? Once again, if you want to develop a skill, register with CDP Labs, Edu Services, so we can develop your skill in the shortest possible time. All right. No. So we did that one. That was $84.70. So now we're going to move on to part 2. Now the lady spends $165. This time they are telling you how much she spent. So she spent $165.31, inclusive of sales tax of 15% on oranges. Calculate the original price of the oranges. Now, The thing about it is that she pays 15%. She spent 15% more as taxes. Now, remember, you're adding 15% to her cost. That's what you're doing. You're adding 15% to it. So, so the tax, the amount that she spent already includes the tax. It already includes the tax. So we want to find out what is the original price. It includes the tax. It includes the tax. Now, how can we understand this? Let's work it out first, and then we look at how we can understand it, right? So this $165.31 already include 15% tax. That means that this amount is 115%. This amount represents 115%. Got that? Now, we can simple, we're experimenting here, experimenting, multiply that by 100 and divide by 115. Well, it's a simple experiment. Then I'll take you back and show you how we come across that. 165.31 times 100, that's equal to 16,531 divided by 150. And then the answer is $143.75. Now, so we have $143.75. Now you want to prove that this is correct. All you do is multiply this by 15% and then add it back to it. So let's find 15% of that and see what we get. So $143.75 times 15 is equal to $2,156.25. I will divide that now by 100. And we get $21.56. $21. So we add that $21 now. So 143.75. And we're adding $21.56 to that. Because that's the tax. Good. The 5 plus 6 is 11. Carry the 1. 8 plus 5 is 13. Carry the 1. Get 5. And 4 and 2, 6. So 165. So we get about the same amount that we start off with first. So the answer to the question, therefore, is the answer to the question, therefore, is $143.75. They might say, sir, I don't understand. All right, simple. If you notice, I just add the 15 to this. Yeah, man. I just add 15 to this. Because really what you start off with is really this. 165.31 divided by 115 over 100. That's really where to start. So or 815 because we add the 15% to it. So you end up having 165 and 31 cents. Change the sign to multiply. Invert the 100 over the 150. So basically, that's a little smart little way. Just add the 15 to that. Just no say multiply by 100. Divided by that now. I get the original price, which is $143.75. All right? Good. Hope you understand that one. If you understand, click the like button and then share the link with somebody else. And of course, you want to develop your skills or get your skills developed, you can register with the institution and get a chance. Or to register with CDP Labs with the services, you go to CDP Labs. You can search CDP Labs Edu, or you go to www.cdpmathlab.com, CDP Labs Edu Services rather.com. And of course, you will get a coupon. So apply now so you can get yourself a coupon, which is 20% discount on the fees. All right. Let's move on to our other question. That is the final question for question number 1, 2022. Now it says the ratio of the number of bananas to the number of oranges is 2 to 3. So the topic here we're looking at is ratio. Ratio. And of course, we'll be doing a lesson on ratio anytime soon. So ratio is the topic right here. And the ratio is being expressed of bananas, number of bananas rather, to the number of oranges. So this is saying for every 2 banana, there's 3 oranges. That's what it's saying. Furthermore, there are 24 more oranges than bananas. So she has given you some bit of information. So she's saying, she's saying the ratio of number of bananas to the number of oranges is 2 to 3. Furthermore, there are 24 more oranges than bananas. That's what she's saying. So let's look at that. There are 24 more oranges than bananas. So whatever number of bananas there is, there's 24 more to it. Despite the ratio. So the ratio is 2 to 3. The ratio is 2 to 3. So the difference of 1 in the ratio, difference of 1 in the ratio is 24. If you realize that. The difference of 1 in the ratio is 24. Let's say calculate the number of bananas Miss Reka bought. All right. Let's see if we can understand the whole idea of ratios now. I need to understand ratio and see how it works. So this is a question you have to actually think. And let's see how we can use again our manipulatives and figure this out. So we're going to do ratio questions, right? There's something called a technique called bar modeling that you can use. The technique called bar modeling that you can actually use to figure this out as well. All right. So let's see if we can find our shapes. All right. So number bars. All right. So this is one. Another one banana. Well, let's go back to the ratio again. So they said that it's 2 to 3, right? So 2 to 3. They said 2 to 3. There's 2 to 3. Um, well, let's not use the number 3 then. We can probably get rid of that. All right, let's get rid of this 3 here. And use a different color. Perhaps the color will make a difference. Banana, well, is normally green. We'll keep it like that, right? Banana is normally green, right? So let's use that. Copy that. So what they're saying, there are 2 oranges to 3 bananas. That is the ratio. That is the ratio. But note, what I want you to note that I want you to note that it says that there are 24 more oranges than bananas there. All right, let's get back to the question and be certain of that information. There are 24 more oranges than bananas. There are 24 more oranges than bananas. So let's write that information here. 24, well, kind of erase this. So we want to change the color to black so you can read. So there are 24. Let's start over back in black. Good. So there are 24 more bananas. Check it again. 24 more oranges, rather. 24 more oranges. Oranges than bananas. Good. Now, so there are 24 more oranges than bananas. This is the ratio of oranges to bananas. Good green bananas, I would say. Now, there are 5 fruits right here. But she's saying that there's 24 more oranges than bananas. Let's see how much marks the question now. It's 2 marks. So it's not that difficult. And they're asking you to calculate the number of bananas Miss Rika bought. Okay. Number of bananas that she bought. Now, so even though there's 24 more, we're going to see now how we can get that answer. This is 2 to 3, one set. So that is 5 fruits. Then 4, keeping the ratio to 6. That's 10 fruits. Now remember now, that in one set, there's 24 more. Good. Let's continue. we can keep the ratio going. If you have the same thing, 6 to 9, well, keeping the ratio. So we're doubling up the thing now. And this will be what? So 2 to 3, 6 to 9. Because this is 2 to 3 too. Now we have 6 and 9 is 15. All right. Remember now, we need to maintain the ratio. So this side, even though the ratio is higher on this side, but technically still enough, you can simply multiply the 2 times the 24. And you will have, we're going to test out something. Ready? We'll test out something here. 2 times 24 give us what? 48. But remember now, we want to keep the ratio what? 2 to 3. Good. Now, all right, let's keep say we can do it. So 2 to the power of 3. Then we have 48 here. To what? Oh, we'll find an answer then. So 2 times this, 2x. 3 times 40. Let's see that. We're experimenting first. 3 is 24. 3, 4 is 12. And I just doing this like our regular math student should do it, the experiment. Nothing to worry about. Good? So 3 times 8 is 24. Carry over the 2. 3, 4 is 12 and 2. 144. And divide this 144 now by 2. 144 divided by 2, we're going to get 72. So the ratio is 48 to 72. So the question is then, what is the difference between 48 and 72? 40. So next minus them and see what we get. So we get 6 right here. 8 from 12 is how much? You tell me. 4. And 4 from 6. Oh, so you see? 24 more. Well, what we see right here, the ratio from here is 2 to 3. But this is saying that she has 24 more bananas than oranges. With that 24, but that should not be the case. That should not be the case, right? So could it be then? Here we have a ratio. If it was 72 to 48, but the ratio would then be spun around where it would be now 3 to 2. So I've seen really the 24 difference, but the ratio is 3 to 2 in this case. But this still saying to us that there's 48 bananas and 72 oranges. Because remember, she buy 24 more than. She buy 24 more than. No, there's another way to look at it. This one difference represents 20. Let's just say the one. No. If you buy 24 more oranges than bananas, this is saying in this case that she bought more bananas than oranges right here. Was it saying that we bought 24 more oranges than bananas? Good. So if it is then, all right. We're just trying out something. Just trying out something. We can continue this trend, reckoning, until we reach a certain amount, wherein the difference between the two is not, it is actually 24. We can do that. Let's try that first. Note, we have a projected answer to be 72. All right? But we're going to try now something else. So our projected answer is 72. Please note that. Our projected answer is 72. All right. Let's see. Uh, Something to come back. All right. So let's continue with our record. So this is 8 to 12. Good. The ratio is still 2 to 3. But the difference here is now what? 4. Difference is 4. If we multiply this by 6, let's see, the difference is 4. And if we can multiply the difference of 4 by 6, we get a 24 difference. Let's multiply 6 times 8 then. 6 times 8 is what? 6 8 is how much? You will tell me. You can tell me in the chat if you wish. What is 6 times 8? 48. And then 6 times 12 is 72. So you notice the difference is 24. The difference is 24. That ratio is still 2 to 3. But the difference is 24. And it says that she bought 24 more oranges than bananas. Let's look at it. Calculate the number of bananas Miss Rika bought. So furthermore, there are 24 more oranges than bananas. 24 more oranges than bananas. No, this is not this is saying though that there's more bananas than oranges. Maintain here. Let us add 24 to this then and see something. If we should stick to the same ratio. Now, if we add 48, we're just checking on something. And this 24 right here, if we add 24 to this, we'll end up with in what? 72, which should now make it a 1-to-1 ratio. But it is not a 1-to-1 ratio. It is not a 1-to-1 ratio. Certainly not. It is not a 1-to-1 ratio. All right? It's not a 1-to-1 ratio. Because if there's more oranges than bananas, and you want to maintain the same ratio, 2 to 3 or 3 to 2, where the bananas, there's 24 more bananas, 24 more oranges than bananas. So if the number of oranges increase and become greater than the number of bananas, that means we're not staying true to the ratio. So the difference right here is 24 in this ratio right here. Then therefore we'd have to now say that the number of oranges is 72. The number of oranges is 72. That is 72. Okay? All right? So we're going to move on from here. All right? Let's move on from there. All right. So we're finished with this question. Now we're going to May, June 2019. We're just wrapping up, quickly wrapping up. Again, you can use a calculator to evaluate each of the following. 2 1/4 minus 1 3/5. Divide by 3. Now, in a question like this, you're first going to perhaps um, do work, calculate, or compute the first part of the question, or the top part. The top part. This is this part of it. No, just find the difference between these two mixed fractions. Then you find the quotient now when you divide by 3. Again, some persons might not know how to. So we're going to use our manipulatives now and show you how it is done. All right. Let us continue. Trying to make it easier for you to understand as we go along. All right. So we use our fraction box. So 1, got the question again. That's 2 1/4. So we need 2 wholes. And we can take another whole and divide it into quarters. Let's divide it into quarters. And we only need what? 1/4. We only need 1/4. So let's get rid of these. So we split them up. And let's erase this. So we're left with now 2 1/4. And we should now subtract. And I wanted to know, we're supposed to subtract. And let me write the question down so you understand why I'm not going to represent the other one naturally. So 2 1/4. So in real life, represent this as 2 1/4. But how much you're going to take from it now is simple 1 3/5. 1 3/5. Now, when you're subtracting, and I want you to think, this quantity supposed to be into this. So you do have to represent this because this is already a part of this. Agree? No. So guess what now? What are we going to do? We're taking the 1 from the 2. So let's take the 1, subtract it, leave it right here. So what we have left is now what? 1 1/4. Where that 1 come from? See it here. This one tell us that we take away 1 from it. I will take away 1 whole. But we have not taken away 3/5 as yet. We have not done that as yet. Now we have an extra whole leave, which you can take 3/5 from. So let's do that then. Now to take 3/5 from the extra whole, then we have to now divide the extra whole into what? Fifths. Here we go. So we take away now 3/5 from it. So 1/5, another 1/5, another 1/5. So that's 3/5. So now we have taken away everything from the 2 1/4. So what we have left now is 2/5 1/4. So what we now have left is 2/5 1/4. That's what we now have left. But guess what? You want to express it as a single fraction. Now, to express it as a single fraction, they will have to add them. No, they have to be the same size for us to add them. And let's see what happens. Now you can observe and see what happens. So we can merge them. Merge can merge. So we'll split this up. Split this up. Still not the same size as it. So we keep looking to it the same size. Split this up. Still not the same size. So we keep looking until we find the same size. So we'll continue. So now everything are the same size. So now everything are the same size. So 1/5, 1/5, and a quarter. So if you notice, all we have to do is just multiply the denominators. I'll get them to be the what? Same size. So we can now count up everything. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So therefore, the answer then would be equal to 13 what? 20ths. Simple. So we just split them to the same size. Now, if it is that they met them, and I want to show you something in the calculation, 5 4 is 20. But we have to make whatever we do to the denominator, we must do to the numerator. So with 8 over 20, as you can see, I count these to get 8. Plus 5 of these, 5 ones 5, and 5 fours 20. And they add them up, and you get your answer. Simple. Good? Simple 1, 2, 3. So this answer, of course, is 13, 20. Oh, well, we're not done it, actually. We're not done it. We're not done it. So the top part of it is 13 20ths. Now, this 13 20ths now must now be divided by 3. Must now be divided by 3. Now, what we have learned from the last question, how many times we can get 3 into 13 20ths, brother. Not 8s, but 20. Mistake right here. Good. How many times we can get 3 into this? Now, that is what is being asked here. How many times can 3 go into this? All right. So we have 20ths right here. Now, if you notice, it is asking how many times you can get 3 into 13 20ths. That's why it's asking how many you can get 3 to 4, a whole. Now, that is 3 wholes. That is 3 wholes. Right? That is 3 wholes. It is 3 wholes. But this is not even one whole. But this is 3 wholes. So the question is then, the answer then, of course, is going to be a fraction. It's going to be a fraction. Good. The question is, what fraction of the whole, the 3 wholes, is 13 20ths? That's the question. What fraction of the 3 whole is 13 20ths? Now, one whole, we'll look at it. Just want to understand now how this thing will work. So what the division component, let's try figure that out, right? We showed you how to do this already. Now, this is 13/20, which is a fraction of one whole. Good? Fraction of one whole. If you want to put it, it's a fraction of one whole. If you have another whole, however, it's another fraction of 13/20. Again, good? And then that will be 60 parts. That will be 40 parts, in part. This is actually all right. Let me show you now. In abstract terms, you'd have 13/20 times 1 over 3, which will give us 13/60. So this is what the fraction is. Remember, you have to make them the same size. See, I'm going to make the thirds into 20ths. That's it. The thirds don't have to come into 20ths. I want to see how that works out, how that pans out. So again, you're going to be the same size. So 13 over that, and you have to multiply this by 20 to make it to be the same size. This by 20 with the same size. So you end up having what? 60 over 20. But remember the division sign remains the same right here. And they will invert times 20 over 60. And divide that into that, and you get the same 13/68. So you can therefore make this be the same size as this first. Then you rewrite it like that, change the sign, invert, and it become easier to work out. All right. So again, we can take the 3, take 3, but remember now we want them to be the same size. The same size. Same size. If you break this down actually 60 over 20, it work out to be six halves. 6 halves. 6 halves. So here we have 2 halves, 3 halves, 4 halves, and 6 halves. So we have 6 halves right here. Because if you divide this into this, you get 6 and you get 2. 6 over 2 is really 6 halves the same as 3. 6 halves. Now, if let's see how we split this now. There's 6 halves. All right, let's see. I will split this. All right, good. Now, if you were to count them, you have one set of 13/20. We're checking it out now. So we're checking it out now. That's why I see what is going to go. What we're doing right here. So good. So we don't want the class to go too long. So after you take a break and resume tomorrow, complete day 1 exercises so that you can get a full understanding. So of course, subscribe so you can see what's going on. Now, if you count, if please note, no, I want to note something. We're talking about how many times 3 can go into 13/20. So we have a fact, we're dividing up the 13/20 into 3. That's really what you're doing. Because if you have 6 divided by 3, just want to show you something. If you have 6 divided by 3, you're asking how many times 3 can go into 6. That means you're dividing up this into 3 parts. So, therefore, we're getting 3 groups of 2's. So, in each group, there's 2. So, you're dividing up and you realize that these are thirds. So, you're dividing, what you're really doing is dividing up this into 3. The 13/28. All right, so let's fix it up here then now. Get rid of this. Get rid of this. So you're dividing up again these into 3. So let's see what is done. So if we're going to divide this, we have to divide this into 3. So 1, 2, 3. And what you get there is 6. I'm going to show you. Divide this set into 3 too. 1, 2, 3. And see what you get. Divide the 3 too. 1, 2, 3. Well, um, I make a mistake here. Make a little mistake here. All right. So we're going back. So divide into 3. So 1, 2, 3. Well, something not going on right here. This is what? 20th. Let's rename this. 20th. All right. This is 4. 4. Oh, but there was a little problem with this one. There's a problem with this one. So I think we are probably, let's see. This is 4 and 4, 8. And then we have, then this is 4 and 4, 8, 9, 10, 11, 12, 13. Okay, good. So what we need to ensure that they're the same size. So we'll split this one, but we're getting 24 right there. So we're not getting the same thing right there. All right. Oh, it is 4, and this is now 6 pieces. All right, so let's see if we can rename it again and see something here. All right, so let's split this then and remove this out of it. I think, all right. So we can now get that, let's see. And then we split that. Good. So we split this now. Now I forgot to do something to that. Well, see what is happening here? So here we have our threes. It wasn't an even number amount. And now we have thirds. So it wasn't an even number amount. If you understand what's going on here. Good. So let's see what's happening now. So continue to do this now. So we're going to rename this now. So that's our second time. Our second time. Our second time. So our third time. Our third time. And our third time. Now, so let us see then what color is this? What size is this? So when to increase it so you can see. All right. So this is 35. All right. So if we can reduce it a bit upon it. Okay. All right. So let's continue. So we get that. We got that. But we still not get what I look for yet, right? So we can rename it some further. Rename it further. Rename it further. The aim is to get the 168, right? All right. So we got that. We're making it the same size. All right, let's say we can carry this to 168 then. So we're now at 168 right here. 168. Good. So this have to give us 168. And let's see how much of that. So two 168 makes up 128. Well, actually, three of them rather. All right. So now we have our 13. 13s. We now have 13 28ths, which is how much? Let us see, So we have to divide it into thirds. Divide it into thirds. But remember now, that is three wholes is what we want to get. Three wholes is what we want to get. But remember, that is just fraction. Just a fraction. It's a fraction. Now we don't need this. I'll put this into the mix of things. And if it's just a fraction, just a fraction. It is 13 of this. So you talk about three wholes. And that says 13/68. Good? Three wholes. So it's a fraction of it. A fraction of it. Because we rewrite the 3. So we'll wrap it up here. Wrap it up right here. So we have 13/20 divided by 3. So we have to divide this. But what we notice though is that as we divide this into 3, we're going to end up getting 13/68 as the answer. Because we divide to 3. We actually divide up 13/20 into 3 parts. Good. But we end up with a fraction, less than a whole. So it is 13/68. But what I want to get from the whole activity of the fractions, basically, is that you can simply write the division sign again over 1, but make them be the same denominator, which might be easier for you to understand. Divided by 3, 6, 3 over 20. But remember, say you have to multiply this also by the same 20. So it becomes 60 over 20. Good. And then we can say, all right, 13 over 20 times 20 over 60. And you can just cancel that. I get the same 13/68. That's it. All right. So we're going to end our lesson right here. And then tomorrow we will resume day number one, part two. All right. And we'll continue. We'll pick up from number one, A part two, 2019. So thank you very much for viewing our channel. And as I said before, if you want to develop the technique, you can in fact um, register with CDP Labs Edu Services. And you can look us up by searching for CDP Labs Edu. And then you take it to a website. You can register there and become a student. Thank you very much.